Example 2. Find the area under the cosine curve from 0 to b, where b is in between 0 and pi over 2. Okay, let's take a look at Desmos, and let's go ahead and graph the cosine curve. So we have the cosine of x, okay? But we're interested in the fact that the lower limit is 0 and the upper limit is pi over 2, which is actually b. So let's just go ahead and take a look at this. So if we put in our lower limit of 0, okay, and let's see here, less than or equal to x, which is less than or equal to pi divided by 2. Okay, so what we can see here is this is our curve of what we're dealing with, because we know that the value of b is in between 0 and pi over 2, and we want to find the area of the shaded region. So we want to find the area under the cosine curve from 0 to b. Okay, so the first thing is we need to find out is that we know that the function f of x is the cosine curve. Okay, and so then we need to find out what is the antiderivative of this function. Well, the antiderivative, okay, is sine of x. Okay, so now if we wanted to, now we're going to go ahead and find the area, okay? And so the area is going to equal the integral that goes from 0 to b, because they're asking us to find the area from 0 to b. Okay, so if we put in cosine of x dx, okay, now what is the antiderivative of the cosine of x? Well, we know that's going to be the sine of x. And then we're going to evaluate it at the lower limit of 0 and the upper limit of b. So that means we're taking f of b minus f of 0. So we're going to have the sine of b minus the sine of 0, which ends up giving us the sine of b. Okay, now, if we chose to use this limit of pi over 2, let's just use this as an additional example so we can see what would happen here. So if we wanted to look at this integral going from 0 to pi over 2, we know that this is the cosine of x dx, which gives us an antiderivative of the sine of x that goes from 0 and then pi over 2. So what this means is we would get the sine of pi over 2 minus the sine of 0. Okay, so what does that tell us? Well, that tells us that the sine of pi over 2, which is a sine of 90 degrees, is 1. So what we can say is if we take a look at the graph here, right? Here's the graph going from 0 to pi over 2. And so therefore, if we wanted to use the upper limit to be pi over 2 instead of b, then we would know that that would give us that result. So we can then say that in particular, taking b to equal pi over 2, we have proved the area under the cosine curve from 0 to pi over 2 is equal to 1.